సరే ఉండు, నేను తీసుకొస్తాను. కూర్చో, కాలు కడుక్కో. అలా తీసుకొని చేసిన అలా ఎందుకు, అది ఎందుకు పెట్టావు? అక్కర్లా, తినేసి తినేసి ఆడుకోవడానికి వేరే పెట్టుకొని ఆడుకోరు, పప్పులు ఉంటాయి. తినేసాడు, చాలా కాస్ట్ పెంచేసాడు రేట్. తినేసేసరికి 40 అంట. ఇదివరకు 30, ఇప్పుడే 40.
719075. Good evening, everybody. This is Professor Rajesh C. Jampala from P.V. Siddhartha College of Arts and Science, welcoming you all to the 6-day FDP on manufacturing innovation and organizational excellence. This 6-day FDP we are conducting through ATAL-FDP. I thank very much all the participants for registering and attending this particular FDP. I am very much delighted to share with you all that almost 198 participants so far are registered from different states of this country, ranging from Kottayam to Tamil Nadu to that of Assam and Ghaziabad to the NCR. So all participants are from different geographical areas. As we have lined up a very eminent personalities during the next six days, we request all the participants to attend all the sessions. As you are all aware, the attendance will be taken each session, and minimum 85% attendance must be registered by all the participants to get the certificate. So you have to log into the ATAL-ACT portal at the end of this FDP to give your feedback as well as to attend the online evaluation exam. Then only the certificate will be issued by the ACT. So on this happy occasion, I would like to mention a few words about P.V. Siddhartha College of Arts and Science. The Department of Business Administration, established in 85-87, and since then, we have been in the forefront in supporting the management education in this part of the state. And P.V. Siddhartha College of Arts and Science is celebrating 50 years of its existence. This year being the Golden Jubilee year, we are very much delighted to host this particular FDP. On this happy occasion, I request our beloved principal, Dr. Meka Ramesh, to give his greetings to this. Welcome, sir.
Thank you. Thank you, Ramesh. Rajesh Chaudhary garu. I welcome all the participants to this 6-day long faculty development program, which is sanctioned by the AICTE. And the Department of Business Administration rightly chosen the topic, a better topic in my opinion, which is manufacturing innovations and organizational excellence, which is the need of the hour also, you know very well. All of you may belong to the business administration areas. And nowadays, market competition is there. And each and every firm and each and every the higher cadre or lower cadre people have to enhance their efficiency, and the companies have to increase their productivity. These are all the very needed this is everyone has to focus on these lines and for driving their companies in a sustainable manner. And quality assurance and sustainability, these two are also very important, you know very well. So this Department of Business Administration has chosen, in my opinion, a right and topic for this faculty development program. So this excellence is optimization of performances and also on the long-term sustainability. These are all the very important concepts nowadays. We have so many eminent personalities with us to deliver the lectures on this 6 days program, and so make use of this session very effectively, and it definitely enhances your focus or your knowledge in different areas. Thank you. Thank you very much. I wish you all good luck. Thank you.
Thank you very much, sir, for your message. As we emphasize, this particular topic is most relevant in the advent of India is becoming the major force in the world economy, as we are the leading in terms of GDP growth rates. But at the same time, India has to be self-sustained, as you mentioned. So, as a Make in India program is the thrust area of the present government. So, India has to build the strengths and competitiveness in terms of manufacturing to support the products and services for the 140 crore people. So on this occasion, I once again thank our college management and Siddhartha Academy and the faculty members for supporting this particular event. I would like to invite our beloved director, Sri Vemur Babura, onto this meet. Okay, before he joins, I would like to mention briefly about the 6-day events. So the timing for today's session is from 6:30. The session starts at 6:30. The first session, it will be there up to 8 o'clock. And the second speaker will come at 8 o'clock and it will continue up to 9:30. But on 3rd, 4th, and 5th, and 6th, the sessions will be from 6 to 9 p.m. And we have lined up 2 speakers every day. And the last day, we will start the session at 3 p.m. and it will continue up to night 9 p.m. So this is briefly about the timings. So we still wait for the first session. I think 100 members have joined already. But overall, 198 faculty members from engineering departments as well as management departments have joined. So today we are about to join by our expert speaker, Sri D. Ramakrishna Garu. He'll be joining very shortly, and he is a very senior professional and as well as a technocrat, I should say. He's an entrepreneur and he's built an empire of electronic industry in Vijayawada. So he is going to deliver a very important topic on the manufacturing innovation in the industry 4.0. So now I request Samrat Krishna to mute all the other participants. I request all the participants to be on mute. While the session goes on, I request all of you, if you are having any query or any other thing, you can put it in the chat box or you can raise your hand symbol so that at the end of the session, each speaker will be given. Each question will be, his query will be answered by the experts. Meanwhile, I request all the participants to mute their systems. Just give me a minute. I'll just check with the other guests.
Recording in progress.
గంట పడుతుంది భవానీ
So good evening, sir.
అండి
Sir, shall we start, sir?
గుడ్ ఈవినింగ్ సార్
Good evening very much, sir. Thank you very much for joining, sir.
Good evening, Ramakrishna garu.
గుడ్ ఈవినింగ్ అండి
See. Sorry. Yeah, good evening, everybody. It is an immense pleasure for me to introduce Sri D-Ramakrishna garu. He is a Bachelor of Engineer from Surat, Sardar Vallabhbhai National Institute of Technology, Surat. And he did his MTech from IIT Madras in the year 1981-83. Then he is the founding CEO of Electronic Systems Private Limited, established in 1985. So he is a pioneer in Vijayawada, especially in the electronic industry. He did an immense work in the field of signaling system, I should say. The entire Indian Railways is now run on the support of the electronic systems. So we are very proud of you, sir. So the sir believes in very fundamental principles of management, especially he believes in the concept of identify, create, and deliver value. He is so obsessed with the word value, which that orientation helped him to many innovative ideas and solutions over the 4 decades of his entrepreneurial journey. With a commitment to R&D driven solutions under his leadership, Electronics has emerged as a leading end-to-end smart solutions company, specializing in areas of railway signaling, urban intelligent transportation, and Industry 4.0. Sri D. Ramakrishna garu believes that results are only possible when an organization has passionate people with the growth mindset who are willing to take risks, continuously learn and adapt to changing technological scenarios. With such a learning and collaborative culture, Electronics has indigenously designed and deployed India's largest IoT network for Indian Railways, connecting more than 1 crore signaling elements across 90,000 locations. You can imagine he covers almost 95% of the Indian Railways with his connecting points with IoT systems. The solution has tremendously improved the safety, asset availability, and punctuality in trains. As chief architect of electronic products and solutions, Sri Ramakrishna built many complex algorithms for different contexts. He designed high throughput and cost-effective end-to-end IoT platform stack covering IoT hardware, software platform, mobile apps, and data analytics. To learn more about the latest advancements in technology and best practices, Sri D. Ramakrishna visits world-class trade fairs and conferences periodically in Germany, Spain, USA, Japan, and implements those learnings internally and into products and solutions for his customers. Notably, Aftronics has been hiring, training, and teaming up with fresh engineers coming out of colleges, both the Telugu states, rather than bringing technology IP from other countries. So he's the pillar of the strength for Vijayawada industry. He is the past chairman of CAI Andhra Pradesh, and he has been into the many bodies advocating about the industry issues to the government. So he's in the forefront of many social organizations also. He is a chairman of Amaravati chapter of IT Associations of AP. And is a chairman, Guntur subsection chairman of IEEE. In that sense, he is very much involved in the learning and sharing his knowledge. So we are very much happy to welcome Sri D. Ramakrishna Garu to our sessions. Sir, the session is over, sir. Please.
Thank you, Mr. Rajesh, for giving me opportunity to share my thoughts with the learned people. It is very important that technologies are changing very rapidly. I won't say rapidly, but they are changing. But that has to be used in various places to get the fruits to the country and as well as to the people of the country to get advantage of that. Otherwise, we'll be always behind the other nations and we'll be only doing a low-end labor work, which doesn't really create a value to the country as well as to the people. And that's where I believe that we have to embrace with the new technologies and start using it, not just learning, it has to be used in a regular manner. So let me put this entire story in a different dimensions. First, let me talk about what is Industry 4 and concepts in a simple terms. I know that you are all, most of you are from MBA and industrial engineering backgrounds. So I try to touch very little in the technology, but more on the application part of it and what is it, basic concepts. Now, when we talk about Industry 4, the entire aspect, this particular slide, you might be listening from a longer period. Our physical world has become a hyper world and is not rapidly being augmented with a smarter solutions. So here, somewhere around 1784, industry first revolution started, then second, and then third is a more of a automation started. Fourth industrial revolution is a system of systems because of Internet of Things and high availability and huge complex CPUs available across the world that made the systems more in a different dimensions. Now, I'm not going to go into this at this stage. Let me go into the next stage. Yeah. So what is the difference between a Industry 3 and Industry 4? In general, generally, Industry 3 also has automation, but they are all in silos. That means production is separate and marketing is separate, engineering is separate, like that. Everything is separately handled. And when the inputs has to be exchanged between these two, manually one has to take the output of that and feed the input into this system. That's where the distance between this is going to be always different. And again, time used to take more and the data may not be accurate when somebody is feeding that information. And that's all various challenges. But when internet is more penetrated, Industry 4, where the systems are getting connected to each one so that the actions will be taken in a real time with a zero distance. This making a system is a more complex and more dynamic and all that. So all that, what is that? The new dimension started is one of the direction is the Internet of Things. Previously, we are talking about more of a financial system and management systems. But today, systems are connected with the sensors and that will be communicated through internet or various communication technologies. and the data got analyzed and act on that. This is what is a scenario which is able to connect all the systems into the systems. Thereby, we'll be able to see a lot of complex systems are getting built across the world. That is really changing the world much rapidly. For example, olden days, if I had to start some FD in my bank, I had to write a check and application and send the things to the banker, and banker has to verify this and all that. By evening, he will be able to give the that form which is going to be our FD. But again, when I have to cash it back, again, same thing. I had to send that, and again, he has to verify, and by maybe evening. Today, with the app, one will be able to do everything in a fraction of seconds or few seconds. I can open the FD, and same thing, it reflects. And if I want to cancel outflow, it is going to reflect less than a minute or something. So these are all possible because of the type of technologies available, like highly powerful mobile technology and secure technology and the servers available and the softwares. All that is able to make it. Similarly, if you are seeing some of the things like when we are buying something in a MJAN or something, automatically multiple systems are getting connected. These are all which we are using. That means the moment I want to see some products, I can see that. And after that, what type of material available in what in the manufacturers or the suppliers website, and then identify the price and then show it. And then the moment I order, again, it connects to our credit card number and then bank number. And all these systems are all getting connected, and entire activity is done in a less than a minute or couple of minutes, where multiple systems are getting connected. And after that, again, the entire transportation also done in an automatic manner. These are all in a real time, or the data is will be able to observe, and the entire actions are much, much faster. These are all creating a value to all of us. We are all using it. I am not talking anything new. So what is this system of systems? All these systems are interconnected with the help of internet and various connectivity. And thereby, this is going to be highly disruptive technology, highly complex technology, and very dynamic. Very quickly, it's all happening. That's what I said about the examples. Say, for example, a manufacturing a car, so simultaneously, multiple robots is handling all this and making a product. And one is 4 or 5 robots is holding, and few of them are welding, and few of them are doing all that. And entire activities is simultaneously happening in a real this thing. This is not something happening in other part of the world. Something like a Kia manufacturing in India near Anandpur, it is all happening at present. So these type of technologies is making a very accurate and very precise and high quality and very fast, and reducing the cost. Of course, we'll have a challenge of getting jobs to the people and all that. We'll see what is that going to happen in that way. So going back further, so what is that? It is a complex movements, multiple controls, simultaneous controls, cyber connected systems, and the synchronization is 1 milliseconds synchronization, fail safe, with reliability, precision, speed, and deterministic. So these are all happening in a very much in a real-time activity. These are the present technology which is available. Now, the high-end cars today is all multiple systems are interconnected with multiple processors. Maybe a car may have even something like hundreds of CPUs interconnected, working and removing all the previously lever systems and all. Especially electric vehicles, they are all more of a processor-based system rather than a mechanical manufacturing. Only few levers and few motors are able to control everything, and battery management systems, and majority of the buttons and all that. So these type of systems is coming with a multiple process. Today, a CPU, a low-end CPU costs only something like 16 rupees to 20 rupees. So that is the type of technologies now available at affordable. Now, worldwide, already 280 billion ARM processors were sold by this year, and every year 28 billion ARM processors are sell in the across the world. That means every year 4 times of the human beings number of CPUs were sold. Already 40 times of the human beings CPUs were already in the market. So this is how the technologies are now shifting to the things. So in car as a system of systems, one is a vehicle to vehicle communication, vehicle to penetration, and the vehicle to everything that is looking into the cloud, and again infrastructure, maintenance, everything is getting connected. This is another example of what is a system of systems. These are all now what is that system of systems is doing all that. Just connect to the toll system, traffic system, surveillance, fleet company and insurance company, transport systems. All this is in a real time. This is our system of systems. Now, what is a change in business scenario? Now, the business previously, people to business houses, there is a business. Now, things also started doing business. That means, example, if some organization has say, for example, diesel generator, the diesel generator, when the diesel level goes down, automatically it can order the to the petrol bunk to send the diesel. Once the diesel is filled, if that both are matched, it even verify the bill and passes the bill. Automatically, banker will pay the money, and there is no people interventions. This type of digital business is started. That is what is a previously business to the people. Now people, things, and business. That is what is a new change in business scenario. That is a digital business, which we are all trying to look into. What is this digital business will impact? What you do is going to change. Why you do it, it will change. How you do it is going to change. Where you do it is changing, and who you do it for. So these are all needs a totally new strategies. So as a management people, you have to understand the entire scenario is changing. So you need to build a new strategies rather than the old strategies, which we are all using and learning from a longer period. So who are the stakeholders of the industry? One is the customer. Naturally, he look for a value for money, high quality, low cost, in-time delivery. So same thing, government want more taxes, more employment, higher valuation, more exports. An employee needs better pay and opportunity to learn, better atmosphere, and no discriminations. These are all various things he looks. Similarly, suppliers want more business, better price, and continuous demand. Shareholders wants better profit, better name to the company so that he can exit very quickly. So these are all what everybody looks into it. If all the stakeholders' requirement has to be met, so there is a contradictory things. If somebody wants better profit, automatically you may have to increase the higher cost, or otherwise reduce the taxes, or reduce the salaries. So even better price cannot be given to the suppliers. So there is a lot of contradicting requirements of the things which can be filled or they achieved only by creating a value. So what is value is a overall benefits divided by lifetime ownership cost. So this has to be increased. If the value is increasing, all the stakeholders' requirement can be met very easily. That's where the new dimension or the new strategy should be. We should be able to create a higher value to the customer. So how you do that, create the higher value? So the issue is we need to identify really where you can create that higher value. That's first issue. So identifying that place where I can create the value is the first challenge. Once I do that, so how I create that value is the second challenge. Then once I create that, how I deliver that to the customer. That means how the customer is going to use that, whatever way it is. Then how I scale up. If I scale up, automatically the cost is going to come down and more value will generate. So once we do that, that's not the end of story. We have to continuously refine that value so that you will be edge of the other people where the competition will not be there. So this value story has to be understood as a strategy, and we should build this strategy across the enterprises so that we'll be able to lead the scenario and we will be relevant. Otherwise, if we don't do that, so the organization may collapse. This is where the really the main challenge of that. So business objectives in any organization is one is increasing the turnover, rise profit, time to delivery, on-time delivery has to be. Cash flow management is another important challenge. Return on investment, these are all various business objectives any organization measures the things. So how we have to achieve that? So where you build this business, one is the market penetration to the least risk and diversify is the most risky. So here two dimensions. One is a technology, another is a one dimension is I work in a known technology, known market. That is where very easy to enter into that because there is no risk involved. But the biggest challenge is there is a huge competition. It is a very tough to succeed in that. This is one challenge. The other possibility is instead of working in a known technology, I go to the unknown technology. That's a new technology where product development will take place so that we'll be able to be above the other competitors. That makes something new. See, otherwise, I have a technology, known technology. I go to the different markets, which previously somebody is not doing it. So this is little more risky than the product development, but this is also another area. Otherwise, a totally diversified. That means unknown technology, unknown market, which may have a risk, but once you are succeed, the dividends going to be multifold. So that's where the startup ecosystem has to look only in the diversification, not in the market penetration area. Because the new entrants always has to look into the unknown markets and unknown technologies in such a way that they will be able to create a new dimensions and new systems. So this is what is fundamentally the startup ecosystem has to look into it. Unfortunately, majority of the startup ecosystem is working on the market penetration area, known technology. They are only trying to enter into the competitive area, and at the end of the day, they are not succeeding. So how do business consumption chain happens? So generally in business consumption, the user identify the needs and then he search for the product and then he select the product, then ordering the product, receive the product and install, and then payment is done, use, and then repair, and then dispose. This is called a consumption chain. So in this entire consumption chain has to be optimized. With the help of new technologies, if you are able to optimize this entire consumption chain, you will be able to be successful. This is where really one of the dimensions has to be seen when you are trying to work with the new technologies. So this is where really the entire consumption, there is every possibility to optimize everywhere so that you will be able to reduce the cost to the customer so that end of the day, you will be able to make huge value in this. So the people who are able to implement Industry 4, they are able to get at least 40% higher profit, or otherwise they will be able to grow that much faster. That's what is now the entire world scenario. So what is that has to take is a zero distance. In that, one side you have a technology, another is the people and process, another is the information. With all that, you should take decisions and the connections to the systems in so that the information should flow more quickly and the decisions has to be taken at a higher speed. The things should happen in seconds and milliseconds so that the decision making, if it is zero distancing, automatically the value is going to be very, very high. So this is where one of the possibilities which we can look into that. So this is one of the strategies everyone has to look into it. That's what Industry 4. To do that, or whatever the things now, a lot of people are talking about analytics. So data science and all that, whatever we are talking, this all comes into the analytics. So you have a data, whether this data is coming from a business system or from the IoTs and all, then we have to see what happened. That's the first step of the descriptive analytics. So if you understand what is happening, use human input and take decision and action on that. So this is a analytical spectrum. So end of the day, any thing whichever you do it, that you have to take decision and action. If your decisions and actions are good, that is going to create a higher value. So this is where the differentiator in the business is going to come. That is a decision making and action. So how accurate or how best you will be able to take the decisions. So I will try to take few examples here. So in our organization, we put a lunch feedback system. This is a very simple system which everybody can understand. We have various items here, salad and rice and all this. And we have put 3 buttons, red, green, yellow. That is a satisfaction levels. This entire thing is taken to the database and put into the analytics spectrum. So once we put into the analytics spectrum, what is happening is we put various charts and all that. With this, if you see, so satisfaction is improving or deteriorating. That's one dimension. The second is what need to be addressed to improve the satisfaction. If you see here, curry and fry and pickle, these are the things has a less satisfaction. So we need to address on that so that one can be able to improve this satisfaction level. The second is it problem in the particular day? Because every day we'll have different food items. Only particular day or all the days is the same thing. That's one aspect of it. Then if you take same way, we'll be able to take the right decisions. Because suppose if this data is not there, generally as a CEO of the company, whenever I review with the people who are providing a lunch, general administration, the people will not have satisfaction. Why? I don't have clue. He don't have clue what to do. End of the day, only we'll discuss something and disperse, but nothing is going to happen. But today, with this type of data, what to do and when to do, what is the issues that can be known to the people, and the person who is coming to improve or the review with me, he will come with a strategy. Then if the strategy is right, I can approve. Otherwise, I can ask him to redo the strategy, or otherwise I can give the strategy to him. So this is where the clarity of thought will come into the system. Thereby, the decision making is going to be more effective and it's going to clear the many challenges of the organizations. Another example is this is something like a accident data between Chelkaluripeta to Nellore. So we plotted all that in this dashboard. Now, if you see what happened, what type of accident has happened, what are the vehicles involved, lorry, car, and unknown. These are the bike. These are the higher involved. Where it is, which places it is higher, and how it is happened. Collision brushing, rear end collision, and head on collision. These are the things higher. And what time it is happened. With all this data, we'll be able to understand where this accident is happening, why it is happening, what to do with that. So if you are able to take this type of data picture, whether it is a highway management people or the police or the administration can take the right decisions, what to do in that area, what time they have to do, and how they have to reduce that type of accidents. The strategy can be built, and thereby the decision making is going to be more effective. So these are the various examples of analytics. If you see the first this thing. So here when we are talking, I discussed about a descriptive analytics, what happened. With this, the decision making is going to be much easier. Then second dimension is diagnostic. Why did it happen? The entire science talk about cause and effect. So what is cause and what is effect? If I know it, then the human input is going to reduce and the decision is going to be more powerful, and then action is going to be much effective. So this here, we need to use the technologies like MLA and all that. Similarly, the next dimension is predictive. What will happen if I take so-and-so decision? Then the human input is going to be more, input is reduced and the decision is going to be higher, better, and the action is going to be more effective. So here, for example, if you see our Google Maps, if I want to go to the airport, how much time it is going to take? If I am able to give the predictive picture, I can plan accordingly what time I have to start so that I will be going in a right time, neither early nor late. So these type of already technologies available which will be able to create a predictive analytics. The last is a prescriptive analytics. What should I do? Suppose the decision support, same Google, if you take, if I want to go to the airport, the Google map will tell which direction I have to take, when I have to take left, right, and all that. That is an example of decision support system. Same map, if it is connected to the driverless car, that will take the decisions automation. That means automatically it will take you to the airport without human interventions. That is where the action also taken by the car. This is what is called a analytic spectrum. So one has to understand this type of technologies like analytic spectrum, how to utilize this and apply the step-by-step analytics. Especially my experience says we started using a lot of this type of descriptive analytics, which started giving a lot of value and identifying the failures, identifying the opportunity to improve. All that is now we are able to achieve through this. So with that, generally any management talks about plan, do, check, act. This is a PDCA cycle. So especially ISO 9000 and quality management systems talk about that. Even CMMI level systems talks about this. So plan, do, check, and act. So this type of planning and doing checks previously to collect the data and check and analyze that and act on that, it is to take a lot of time. That means the cycle times to do it is going to be months. Now, with the analytics and IoT, these two things, getting a data and checking and analyzing, is done much rapidly. So thereby with the IoT and analytics, this actions is going to from months to the days. Once we are able to do everything in a month to the days, automatically the improvements can be done much rapidly and the things will improve faster. So which will increase the profitability and reduce the waste and various dimensions of the business. Wherever you are concentrating, what are the objectives and all that. So that's where Industry 4 use case, which will enterprise manufacturing intelligence, know where your resources are real time, when they need maintenance, repair, and overall performance matrix. That can be done so that you will be able to improve the overall efficiency of the system. Similarly, product quality improvement. Test your products for deviations from specification in the real time and feedbacks is data back to the production process for correcting measurements. This also will reduce the waste and quality of the product is going to be much effective and this will make a lot of profitability improvement. Similarly, predictive maintenance aspects, avoid downtime, unexpected services, repairs, and reduce schedules and unscheduled maintenance. These requirements can be improved if you are able to have a predictive maintenance of the systems. There will not be much downtime. Then if you want to predict maintain also, you can have a proper maintenance cycles before failing. That will improve a lot. Similarly, energy management system. Optimize the resource usage by knowing where energy is used most and how to optimize that, what type of missions you can change and what type of improvements you can bring, how you can optimize the total capacity of the power requirements and how to use some other non-renewable energy like solar or wind. Various dimensions can be looked into it. Similarly, what type of equipment is consuming more power? Is it cross benchmark with other companies and see how we can reduce the power consumption? Based on the type of industry, this also makes a difference. Some of the industries use as high as 70-80% of the power. The type of industry, this energy management will help. Advanced automation, that means when you have automation in place, automatically the things will go without wasting the time and without even cycle time is going to be much faster and the product can be made quickly delivered to the customer so that you'll be able to head off the competition and make organizations to be more what is called competitive and take more orders compared to the others. Nowadays, the people want to give the order and want it immediately in the next day. these type of customized products and all without putting a stock, reducing the inventory, all that can be possible in that. Similarly, connected supply chain. So and if you are able to connect the supply chain, the moment people are putting order, automatically you'll be manufacturing and sending it in a 3-4 days, not putting the stocks of the systems and making the things bought for the people's needs. This all reduces the loss of waste and lot of storage and inventory costs and all that. And the entire supply chain is going to be more effective so that the people will not lose the money and automatically customer also get benefited. Systems, they doesn't need much working capital. Multidimensionally, that is all happens when you have a connected supply chain. These are all very few of the use cases which you can use that as a strategy to improve the organizational optimization to create a higher value. These are the few of the dimensions. What we to do way forward. So that means what we have to learn. The greatest danger in terms of turbulence is not the turbulence, it is to act with a yesterday's logic. This is where I like this statement of, because we need to not look into the old books and old strategies. You need to look into the new strategies, how we can work on that. You can fail quickly, but not with the only yesterday's logic. The safe dimensions has to come out of our thinking process. Unfortunately, in India, I see many times which we want to imitate rather than we want to work safe rather than take risk. The risk-taking ability is the most important. We have to nurture the people to take risks, and the risk-taking, without taking risk, you cannot grow. Even previously, when I am talking about market penetration, all that, when we look into it, unknown areas has a higher risk. If somebody is able to take that risk, the dividends is going to be there. If he fails also, you should fail quickly and take the new dimension, and from the failure you can learn more, and from there you have to go to the next level. So these changes has to come into the entire system. That's one thing. So every industrial revolution needs change. That means if you are not going to change, it is going to be more challenging. If you look into the history of many things, so wherever the industrial revolution happened, a lot of old industries vanished and the new industries entered, new dimensions came. All that needs, what are the things? One is the behavior and attitudinal changes. This is a most important. Second is processes and practices has to be changed. Last is naturally this is all happening because of the technological changes. So we need to adopt that new technologies into our industries. This is what is the most important dimensions. So critically, behavior and attitudinal changes is the biggest challenge industry is facing today, because everybody learns from their forefathers or grandfathers, but they don't change because that was totally imbibed into the attitudes of the people from the childhood by the father and grandfathers, what they think is the right when they are young. So from that, how much is change, what is the way to work, all the dimensions, they will not be talking, because the world in evolving, initially there is a shortage of material and shortage of resources is the biggest challenge. But today it's not that. So everybody is able to get food and everybody is able to have no shortage of food grains or not shortage of certain basic amenities. But the challenge is when you are in a shortage area where you born, if you are trying to apply the same thing and to the today, that doesn't work. So the risk-taking ability is the most important, and we need not look to only preserve. We need to look into how to spend and go into the new dimensions. Another important aspect is the process and practices. This also has to be applied in link with the technological changes. So how I can use the technology more effectively in the processes and practices so that I will be able to do better things rather than only mugging up certain things and following the old traditions and old processes, that doesn't really yield much outcomes. So these dimensions is a very, very important in my opinion. When I look into the majority of the curriculums in any of the education system in India, I feel they are all meant for at least 20, 30 years back requirements than today's requirement. We are all training or teaching for the past, not for the future. So this is where I feel even not only in the engineering side, even business management side or industrial engineering side or even medicine or even everything has to be changed. So unless we don't change, it is going to we'll be behind. That's where the things, as previously I'm talking about Peter Dicker's thing, the problem is act with yesterday's logic. That's where the challenge. That means all our forefathers and all that, they talk about yesterday logic, not for the future logic. This is where the change has to happen. That is where the most important dimensions. So today in industry, what we are talking is the capabilities. Previously, we used to talk about skills, knowledge, all that. Today, it's not that. So as I said previously, if we want to get a results, the creation of the value is results. For that, what are the things is needed? One is mindset. That is how we think and what is our behavior and what is our attitudes. And second is what type of practices I am following. All this should get linked with the technology which we are using. Suppose, for example, if I am using something like a dashboards, which I showed, then automatically how quickly I can get a value story from that data and identify where I have to do, what to do, and what type of possibilities I have to look, and quick action to that by looking into the data. If I am able to practice that way, I can take the better decision. Even sometimes my decision is bad also, nothing wrong. So I can quickly change the decision quickly so that the next decision is going to be more better. So the trial and error also doesn't work well in that. So whether you have a mindset of risk-taking ability, so that's where the most important aspect in the mindset. Similarly, whether I want to do it fast, how quickly I want to do it, how I'm thinking on that. I want to be leader in that. So are we having a learning ability? And I want to have other most important dimensions, in my opinion, is two important characteristics is needed for today success. One is a curiosity. That means whether I have a curiosity to learn and identify the new dimensions, why it is happening, how it is happening, what is the new things. So if I have more curiosity, automatically I will try to learn new things. That's the first dimension. Second is when I want to do good things, I need to have empathy is most important. If I have more empathy, I will try to do better things to the society. Once I do better things to the society, automatically that is going to help the creating the value to the society. Once I create the more value, automatically that is going to improve the overall outcomes. So this is where the mindset aspect is a critical, basically, that has to be really look into the every individual, how I am thinking, what is holding me, why, what is my behavior. When I am able to look into the mind, not from the external perspective, by internal perspective, I know what is my mind rather than somebody is talking about my mind. So this is a mindset is the most important. Second is what is the best practices followed across the world and what are the things is happening. And technology, what we said, all this is called a capability. Now, today, industry is talking, what is the capabilities of the people or the capabilities of the organizations, which can really transform to the results. So the capabilities needs to be converted into results. So we have to look into these three dimensions rather than knowledge and skills. Okay, knowledge and skills, I am not saying it's not necessary, but the most important dimension is this, how to build the capable manpower, then through that. So generally what motivates us? So generally the fear is one factor which creates the people to work. So if I don't do well, I may not have better life. I have to be struggling, all that. That fear makes some people to work. Some people get work with the money. That is where if I do well, I will get a lot of benefits and lot of growth will be there. That's where people work for that. Some people says that I will get much fame. My name is going to be there everywhere. Everybody praises me. So that is another dimension. Last is the power. If I get more, I do well. I control the more people and everybody is under me. So that is another dimension. So the people who get motivated because of that, the study says they are not going to build the new solutions and the best solutions to the society. So this is all a behavioral motivational aspects of the people that also has to be looked into. This also comes into attitudinal dimensions. So what need to be looked into? So everyone has to look what purpose I am doing this. What is my purpose? Second is, do I have a mastery in the area where I am working? So how depth I can understand and what is the interconnection things, because today knowing with something like ChatGPT and all, knowing a few things is not a bigger task because systems is going to teach and all that. One has to understand in depth into the area where we want to work it. That's a mastery. Depth and width has to be looked into the things where I am working. The last other point is autonomy. That means independent thinking on the things rather than looking into some book or somebody said. So that is just something like Vedanta. It is just like that. You can't change it. So we need to question it and what is that? Why should be like this only? Reasoning and all that is needed. That makes the output is going to be more better. This is what identified statistically across the world. This is all the things which is making the things much, much better. So for that, what type of things has to be done to create a value? We start think differently about value creation. One is design thinking. So design thinking is one of the way which we identify the needs of the society and the needs of the consumer who is going to use this with empathetically, identify all that needs and then define that things and then make prototype and again test it and then redo the things. This is one of the practice people use to do it. Similarly, there is another way which I will discuss in the later, that is called system engineering. That's one path which we can do it. Another is people should understand psychology of money. That means why I need money, what is that money does for me, what is that happens to me towards that. So as a business administrative people, every student should understand psychology of money. So what is that really the money means to the people and why the people look into the money, what is that does, all that dimensions has to be brought and has to be mastered. And similarly, anatomy of money, how the money will generate money, what is the return on investment, what is the interrelations between profits and investments, and then creating investments in R&D, what it means, and how these are all interconnected things. What is which parameter increases, which parameter decreases, what is the relations between this, that all come into the anatomy of money. So one has to learn anatomy of money, also most important. This is I feel very critical for especially management people. So the last are the new dimension, which many people now talking is because it's the complex systems and the method. So we need to operate with the system engineering approaches. So what is this system engineering? It's a methodology, multidisciplinary approach, which we can apply to that for the design, realization, technical. Don't think design means it's only some product design. Even something like in a banking or in a management also, we can have a lot of design activities that has to be realized with the technology management and operations and retirement of the systems using system principles and concepts, technology and management methods. This design system engineering approach will make the things more effective. So whenever we are trying to produce some product or some solution, that solution should be the concept design. That is where mission needs. That's why you want that. and what are the requirements, architecture of that, functions, what you want to do. All this has to come into the concept design, and then that has to be implemented with a mechanical system or software, electrical engineering, electronics, or any dimension for based on the, this is the one example. That's a product engineering. From that, how this entire cycle has to common system description. This methodology has to be used to understand. Otherwise, when you are trying to read lot of text with multiple pages, the moment you start with one page to the fifth page or 10th page, you forget what is that you wrote in the first page. That's where model-based system engineering, diagram-based documentation has to bring so that we'll be able to visualize the entire system in a one go, and what it does, whom it does, how to use it, how to say configure it, and how if a problem, what to be done. All that has to be looked into it. So what is that has to be done? Need high quality and future-proof jobs. Generally, what people are looking today, what are the jobs which people are doing? More of a routine jobs, which doesn't pay even 20,000-25,000 or even sometimes lower. So when you go into these type of low quality and things will not work. In my opinion, you need to have high quality and future. That means for a long time, this job should be there. For that, I feel system engineering provides such opportunity. So for that, what to do? Develop system engineers from every curriculum. There should be a system engineer, needs curriculum changes, needs holistic practical approach towards that. So now even management many times it's abstract, but the practice should come towards the system engineering practices. So system are deterministic. They need system engineers. AI is just a tool, not the system. Another dimension is AI is more of a probabilistic. That means you are not sure about outcome. Whereas a system engineering is a more deterministic system that makes the things work perfectly and without failures. So today, what are the deterministic systems which you are seeing? The number of accidents happens to the aeroplane, which is a flying in the air, is almost much less than what we are seeing in a railway, which is working on the rails. The next more worst is our automobiles, which are going on a road which is hitting, and every day we are listening, a lot of people are dying in accidents. So which is a more deterministic system is the aeroplane that is done with a system engineering principles. But every possible failure, so every possible dimensions, they will be taken care in such a way that any system fail also, there will be redundant system which will work perfectly. These type of systems is now needed in even financial systems or in industrial processes or even sales, marketing. Every area you need to have a deterministic systems rather than probabilistic systems. Some areas you can apply the probability, but not everywhere. So that's where this is one of the roadmap of the system engineering. That's one of the organization called INCOS, International Organization for System Engineers that put the roadmap. This is adapts to the change global context. So this is where global competition, technology, requirement enforcement, cyber threats, supply chain, all these are the basic dimensions. And the digital enterprises, knowledge and asset, agile and efficient ways to innovation, distributed, diverse workforce. This is a direction at which it starts and delivers systems solutions, including cyber physical. That's where IoT and system of systems and all. Increasing system complexities, what we discussed, interconnected data, software, human interface, interactions, competing stakeholders' expectations. These are all which is increases. So broad applications, all this power, healthcare, transportation, defense. So everywhere it is there. It's not one. So that results in impact environment in the society, natural resources and environmental impacts, climate change and pollution, all that reduces. Global interdependence, pollution, lifespan, social economic conditions. This is the social changes. So growth to the stakeholders' expectation. That's what we are talking about, capabilities, dependabilities, ease of use, scalability and adaptability, sustainability, social acceptance, affordability. So these are all things will improve. So what is that practices? These are the practices, agile, model-based approach, analytic framework, architecting the trust. Trust is a very important dimension for any business. So resilience and other directions. And similarly, tools which are used, AI assist here, say part of digital ecosystem, seamless interactions. These are all various dimensions. So education and training, lifelong learning, technical leadership, competencies, standardized curriculum adapted to the application domains, theoretical foundation and system engineering principles, part of standard curriculum, system thinking, thought broadly across engineering disciplines. These are the system engineering dimensions, which I feel very important, where India, we are not talking, and all these technologies were built by the people from abroad, and we are only doing a low-end labor work without creating much value. So this is a broad dimension. Thank you for patient listening. If any one of you has few questions or anything, I can take up. Rajesh garu.
Yeah, good evening, all the participants. If you're having any queries, you can write it in the chat box. Excuse me, if any participant is having some query, they may raise the issue in the chat box so that the Ramakrishna garu will address you. Otherwise, actually, Sri Ramakrishna garu addressed very elaborately the important dimensions of Industry 4.0. This is about overview of Industry 4.0, key technologies and concepts. As he highlighted about the importance of value orientation and what is value, how you should communicate value, how you should deliver value. At the same time, he highlighted about the emergence of CPUs and IoTs dominating than the number of human beings in the world. And the number of, it is evident in the form of the sales of IoTs and chips. So that in future, we are more connected with the devices. So Internet of Things is a big thing. And he also explained with some use case models like the importance of system of systems. And he has highlighted about the business analytics, importance of diagnostic and predictive and prescriptive analytics in terms of solving the social issues also. And being mostly faculty of the management, he highlighted the importance of PDCA cycle. And with the importance of IoT and analytics, with the advent of IoT and analytics, the PDCA cycle could be reduced further so that the response time will be enhanced. So these are the important things for the management faculty in terms of building efficiencies so that the managers can take the decisions with the zero distance. That means the decision making is almost will be done at real time with the help of the technology. and he has highlighted the importance of design thinking and psychology of money and anatomy of money. Because money is having its own value in terms of giving some comfort, no doubt about it, but the whole purpose of life is to create or identify the real purpose of the life itself. And he highlighted about the mastery over the subject, mastery over the domain you are working, or how much freedom you are enjoying as an autonomy. So these are the three important points in terms of redefining and reorienting yourself in terms of what I can say, your own personality. So with this, I think he has given us the dimensions of both technology and management perspectives about the very important aspects of the industry, how it is heading us, how this technology is taking us, the way we relate, the way we connect, the way we take decisions, the way we order things, or the way we use things in future or at the moment is very much dominated with the importance of the data and how best you will be accepting the data as a new oil. People will say data is the new money, data is the new oil in that context. So we profusely thank you, sir, for
There is
spending
a
your
few-
valuable time.
Rajesh, there are few questions, I think. I
Yes,
will
sir,
try to
right.
take in a simple dimension. One put something like, will the AI being bring down the job opportunities? Yes, for some people it is going to be, where routine jobs is going to be there. Even it can generate code or it can do some routine activities. But the opportunity is when somebody is going to learn system engineering, the new dimensions is going to come and which can create a wonderful systems across the world. So there is a new opportunity, but the people who don't learn and who want to be in a routine jobs, the future is going to be little tough for them. That's one dimension. But they have to learn new technologies and new methods to be in race. That's my understanding about AI. But AI just one is a tool, in my opinion. It's not going to be, unfortunately, people are over expectation on the AI, but AI has its own limitations. That's more of a probabilistic technology. Certain areas, yes, you can use it, but not all the areas. That's another one dimension. Another is sir, you have well defined about AI. Could you please also tell us how can we align systems with AI to prevent accidents, as you mentioned in your presentation? No, I didn't started with AI. I started with analytics. So in Vijayawada, between 2014 to 2019, we put all the accidents data of Vijayawada into the analytics roadmap and given it to the committee where they are analyzing collector and the various stakeholders. So at that point, the decisions used to be taken very effectively. That at least that 5 years, the number of accidents is standstill. It doesn't increase, though traffic and all that is increased at least 2 to 3 times. So the actions which they take it through the descriptive analytics, not with the AI and ML. So that's one thing. And semiconductor manufacturing is the need of our how to visualize semiconductor parks and how it may create jobs for future engineering graduates. So this is one of the challenging area. Unfortunately, in India, we don't change the curriculum. Still, engineering curriculum is a way behind 20 years. And unless we don't change the curriculum towards the new directions, and it's going to be tough. At least till now, AICT is not changed the curriculum. It is still very old. They are still talking about a picture tube technology. I think one has to change quickly the new dimensions of the curriculum and start training them in the new directions. Then only the jobs can be sure about to the people. Otherwise, I think it's going to be tough. Of course, how design thinking plays a vital role in the job role. So generally, how to solve the problem, what is the problem. Once somebody is able to put the mind on that, then automatically one can improve the things. Otherwise, improving is a very difficult. So the knowing wants and the needs of the people sympathetically rather than what is called not liking the people, because this is a big problem to me. So this empathetic solution will bring a lot of dimensions to know why the root cause of the problem, how to eradicate the problem and all that. So that's where design thinking structure is good. Even in my opinion, compared to now design thinking, system engineering is much better, which will be able to address more problems. Sir, could you know why some industries have been ended and when there is no dearth of raw materials? My feeling is we have a less leadership in the entire technological landscape, or the new leadership which want to lead the technology. And as I said about the purpose and the mastery and autonomy is needed to build the solutions. That is missing in my opinion in the entire country. That has to be brought down through the education system. The biggest challenge in my opinion is a education system, which is in my opinion, orphan. In India, education is the biggest orphan, which you need to look into it in order to make great India. Okay, thank you.
Sir, there is a question like these days people are using AI for everything, but not for common sense. What is the solution?
Of course, what for we are using, I don't know. Except my understanding is few of the directions. One is identifying the voice recognition or the pictorial recognition. These areas somewhat matured. Other is something LLMs like ChatGPT or at least average code generation. Yes, these are the areas AI is matured. Otherwise, I don't think AI is matured beyond that.
Yes, sir.
There is not much use case available with AI, even to the, because I go to the international trade fairs, I meet all big giants like Microsoft, Amazon and Google and all this. They are struggling to get some use cases for their algorithms.
Yes, sir. Sir, actually, your session is very insightful, sir, for many of us, as you have touched all the points about Industry 4.0 and the key challenges, and you have also cleared the misconceptions about AI also. AI as a tool, not as a system, is a very wonderful thought. It gives us some perspective. At the same time, sometimes the hype creates some issue. But as you said, simplification is the most complex thing, as the business is nothing but to make the business organizations more simplified. So in that sense, still the human being plays an important role even in Industry 4.0. So with this, I think we can end this session. I think there are no more queries here. Sir, I profusely thank once again Ramakrishna Garu for sparing your time at the fag end of the day. Still, you are in the office for our own purpose. Thank you very much, sir.
Okay, thank
very
you.
kind of you.
All the
Sir.
best.
Thank you, sir.
Yeah, all the best. Bye.
Namaste, sir. So I request all the participants to rejoin for the second session today at exactly 8 p.m. Because we will take we'll have some short break here, and we are having another important guest here today, Sri Murli Krishna Vasireddy. He's also representing one industry association. He's talking about business impacts of Industry 4.0, opportunities and challenges. I request all the participants to rejoin once again without fail at 8 a.m. Thank you very much. Sorry, 8 p.m. Thank you, sir. No, sir. Joiner, sir. Joiner, okay, we'll start. Then ఒకసారి introduce us. Okay. Good evening, everybody. Welcome you all to the second session of first day program. As you're all aware, we are organizing 6-day faculty development program on manufacturing innovation and organizational excellence. Today we have with us a very eminent industrialist as well as a thorough professional entrepreneur and a leader of the industry in the name of Sri Murali Krishna Vasireddy. Is going to deliver a talk on business impacts of Industry 4.0, opportunities and challenges. Let me have the privilege of introducing Sri Vasireddy Murali Krishna garu. Actually, he is an executive director of Kavuru Constructions Private Limited. He successfully oversaw completion of 3 major projects and is a managing partner of GC Chemicorp since 1999. First Construction Chemicals Manufacturing Unit in Andhra Pradesh. He is a proprietor of GC Supplements, established venture in Andhra Pradesh in 2012, focusing on in-house construction chemicals laboratory facilities. Apart from his entrepreneurial journey, he is very active in industry associations and different trust roles. Let me present before you his leadership activity as far as industry associations are concerned. He is currently the president, Federation of Andhra Pradesh Small and Medium Industries Association, FAPSIA, advocates for MSME welfare, formerly treasurer and general secretary. And he is also general secretary, Newsweed Industrial Park Association, promotes industrial park development. He is ex-general secretary of Mallavalli Industrial Park Association. He is a vice chairman, South India MSME Joint Action Committee, a general secretary, Kalva Pamla Seva Samiti, who focuses on village development in rural Krishna district. He is a president, Vasireddy Abhyudaya Samiti, provides student financial support and career guidance. He is an ex-executive member of SPSH School, Old Students Association, Guntur. And the state government is also taking his help in many committees. He was appointed as a member of several committees. As a regional advisory committee member, Central Institute of Plastics Engineering and Technology, a member Andhra Pradesh Micro Small Industries Facilitation Council, a member State Level Incentives Scrutiny and Verification Committee, member State Land Alienation Subcommittee, member GST Grievances Redressal Committee for Andhra Pradesh, member GST State Level Trade Advisory Committee, member State Level Civil Supplies Standardization Committee, governing council member, Central Institute of Tool Design, MSME, Hyderabad. So he has achieved several distinctions as a FAPSIA president. Some of noteworthy are influenced policy changes for MSME Udayam registration, organized MSME Mega Expo 2020 with sector-specific panel discussions, conducted seminars, meetings, and MSME VDPs in 2022 and 2023. Established MOUs with VIT AP and KL University for startup guidance. Successfully sought clarifications on work contracts from MSME DC. Hosted International MSME Day 2024 with Honorable MSME Minister and Secretary, Industries and Commerce, Andhra Pradesh. He formed strategic partnerships in healthcare and accounting solutions for FAPSIA members. With this brief introduction, I now present to you Sri Vasireddy Murali Krishna garu, the industry leader and a successful entrepreneur, and is going to deliver a talk on business impacts of Industry 4.0, opportunities and challenges. Over to Murali Krishna garu. Namaste.
Thank you, Rajeshwari. I would like to express my heartfelt gratitude to the Department of Business Administration at P.B. Siddhartha College of Arts and Sciences and Dr. Rajesh C. Jampala Dean, for offering me the opportunity to participate in today's online faculty development program. I'm honored to share my thoughts on the topic business impacts of Industry 4, opportunities and challenges. The presentation I'll deliver is based on my personal experiences and insights gathered through various media sources. I recognize that the esteemed faculty members present today possess far more knowledge than I do. Nevertheless, I hope to offer insights from my perspective. Industry 4 requires automation from raw material sources, production, processing, package, inventory management, and logistics management, which can be referred as supply chain management automation. I believe that change is never easy, but always possible. With this, let us go to today's topic. I think I can share my screen.
Amrad, you can guide sir for sharing the screen. Actually, there is a share button, sir. Okay.
Yeah.
Sir, you have a button that share at the bottom, sir.
Yes. I'm sharing it. Just I'm maximizing the.
Yes, sir. No issues, sir. Thank you.
Yes, sir. It's visible.
Yeah. And overview of Industry 4 technologies. Industry 4 refers to the fourth industrial revolution, characterized by the integration and advanced technologies in manufacturing. The key technologies involved in Industry 4 are Internet of Things, artificial intelligence, robotics, big data, and smart manufacturing systems. The purpose is transforming industries by creating interconnected, intelligent, and automated environment. Let's have a look about the industry evolution. Industry 1, mechanization with water and steam power, which was done in 18th century. Industry 2, mass production and assembly lines in 19th century. Industry 3, automation with computers and electronics, late 20th century. And now our topic, Industry 4, cyber physical systems, IoT, AI, and robotics, 21st century. What is IoT in Industry 4? IoT refers to the network of physical devices, vehicles, machinery, and more embedded with sensors and softwares to connect and exchange data. The applications of IoT are real-time monitoring and asset tracking, predictive maintenance, supply chain automation. Benefits with these are increased efficiency, reduced downtime, enhanced decision making. Next comes to artificial intelligence in Industry 4. AI refers to the simulation of human intelligence in missions programmed to think and learn. The applications are predictive analytics for maintenance, quality control using machine learning, optimization of production processes. The benefits are faster data processing, improved accuracy in decision making, automation of repetitive tasks. Robotics. The role of robotics in Industry 4. Robotics involves the design, construction, and use of robots to perform tasks autonomously or semi-autonomously. The applications, collaborative robots may be called as cobots in assembly lines, material handling and logistics automation, inspection and quality assurance tasks. The benefits are increased production speed, precision in tasks, reduction in labor costs and safety. And next comes to smart manufacturing systems. Smart manufacturing uses data analytics, AI, and IoT to create highly efficient, flexible, and responsive production processes. The key features are integration of machines, devices, and systems, autonomous decision-making and real-time data processing, customization and scalability in production. The benefits are reduced operational costs, agile production systems, enhanced product quality. And the role of big data is also very important. Big data as well as analytics in Industry 4. Data-driven decision making, predictive maintenance, and quality improvement are possible only with big data and analytics, data analytics. Large complex data sets generated from devices, sensors, and processes within the industrial environment. Manufacturing companies using data-driven insights to adjust production lines in real time, reducing waste and improving throughputs. Role in Industry 4. Big data and analytics enable real-time insights, predictive capabilities, and smarter manufacturing processes. The key technologies for big data: Internet of Things once again, cloud computing, machine learning, and artificial intelligence, data analytics platform. Data-driven decision-making in manufacturing, using data analytics to drive operational decisions, enhance product development, and gain insights into customer behavior. Key areas impacted by data analytics: operational efficiency, real-time data analysis to optimize production schedules and minimize waste. Product design, analyzing customer feedback, usage data, and performance metrics to create better products. Customer insights, understanding the customer preferences and demand patterns through data to customize products and services, where customer is very important. So based on the customer insights, we can enhance the product development. Influence of big data in operational efficiency. Data sources in manufacturing, IoT sensors and missions, tools and production lines, mission-generated data, for example, temperature, pressure, vibration, and volumes. Supply chain data, for example, inventory levels and shipment times. Optimizing operations, real-time monitoring, immediate identification of inefficiencies or bottlenecks. Process optimization, using historical data to refine manufacturing workflows. Energy management, analyzing energy usage patterns for cost reduction. The overall benefits to this is reduced downtime, lower operational cost, increased throughput, and resource utilization. There are some other advantages like minimization of accidental risks and all also. We'll go to that topic later. Impact of big data on production design. Customer-centric design. Analyzing product usage data, feedback, and complaints to identify areas for improvement. Predicting market trends and consumer behavior. Design iteration and innovation. Using data to test new designs and prototypes virtually before physical implementation. Without testing these prototypes, if we go for a physical implementation, several startups are failed nowadays. Leveraging data from R&D to streamline the product design process. The advantage with big data and product design is a company using data analytics to improve the durability and functionality of its products based on real-time feedback and performance data from customers. Customer insights and personalization. Data analytics for understanding customer needs, using data from IoT devices, CRM devices, which is customer relation management systems, and social media to better understand customer preferences. Customizing marketing strategies and product offerings based on insights from data. An example for it is a manufacturer using data to customize products in real time based on individual customer demands or feedback. Benefits are more targeted products and services, improved customer satisfaction and loyalty, faster response to market changes. Predictive maintenance using data analytics. One moment. I think the screen was not full screen. Just I'm changing it. Predictive maintenance using data analytics. Predictive maintenance uses data analytics to predict equipment it will fail, enabling preemptive maintenance actions. How the predictive maintenance works with data analytics. Collect the data from sensors embedded in equipment, whether it is vibration or temperature or pressure or volume. Analyze patterns to predict potential failures before they happen. Use artificial intelligence and machine learning to continuously improve predictions. The benefits with this: minimize the downtime by preventing unplanned breakdowns, reduces maintenance costs by addressing issues before they escalate, extend the lifespan of machinery and equipment. How predicting maintenance improves operational efficiency. The first thing is reduce downtime. Maintenance is performed only when necessary, minimizing time spent on unnecessary checks. Cost savings prevents major equipment failures that could be costly to repair. Optimize resource allocation. Focus maintenance efforts on high priority equipment, improving overall system reliability. An example for it is a manufacturer using predictive analytics to track the health of its mission and schedule maintenance only when needed, reducing unplanned downtime by 40%, which is really a good downtime. Improve product quality with the data analytics. The product quality can also be improved with real-time quality monitoring, analyzing sensor data from production lines to detect quality deviations in real time. It is also useful for root cause analysis, identifying factors that affect quality. Example, the temperature or machine speed using historical data. Implementing corrective actions based on insights delivered from data. Quality control automation, using machine learning algorithms to identify defective products and remove them from the production line automatically. The benefits of these are fewer defects, higher product consistency, enhanced customer satisfaction. Ultimately, customer satisfaction is very important for any product. So it will support enhance customer satisfaction. Predictive maintenance and quality improvement. A global manufacturer of industrial machinery implements predictive maintenance and real-time quality control using big data analytics. The results are 30% reduction in maintenance cost, 20% increase in product quality by reducing defects, 15% improvement in overall equipment effectiveness. The key benefits with Industry 4 technologies are enhanced efficiency, automation and optimization of production processes, cost savings, reduced downtime, maintenance costs, and wastage, increased flexibility, the ability to adapt customer needs and market changes, improved product quality, precision in manufacturing and real-time marketing. The future of Industry 4 would be the trends: expansion of 5G or new generation networks enabling faster IoT connections, increased use of AI and machine learning for autonomous systems, growth of edge computing for faster data processing. Vision is fully connected, automated, and optimized production systems. The overall Industry 4 is a transformative wave in manufacturing powered by IoT, AI, robotics, and smart systems. Future outlook. Ongoing innovations will continue to drive efficiency, flexibility, and customization in industrial industries globally. Once again, the future of big data and analytics in Industry 4. Emerging trends, increasing adoption of AI and machine learning for real-time analytics, advanced data visualization tools for better decision making, real-time data processing at the edge, which will be called as edge computing, vision, a fully integrated, intelligent manufacturing environment where decisions are made autonomously based on big data insights. There are more challenges also. The first challenge is high initial investment, expensive set of costs for IoT, AI, and robotics, which are not immediately possible to micro small industries at present. Cybersecurity risks, increased data sharing and connectivity lead to potential vulnerabilities. Skill gap. It is very important need for a workforce skill in new technologies. Integration complex. Aligning legacy systems with new smart technologies. And the challenges of implementing data analytics also in Industry 4 are data integration, integrated data from different sources, like it can be from IoT emissions, supply chain into a cohesive system. Data quality, ensuring accurate and clean data for reliable insights. Once again, skilled workforce, need for data scientists and needs to interpret and act on data insights. Data security, ensuring sensitive data is protected from breaches and cyber threats. The key takeaways are big data analytics are crucial for driving efficiency, improving quality, and enhanced decision making in Industry 4. Predictive maintenance and data-driven quality improvement offer substantial cost savings and operational benefits. The future of manufacturing relies on continuous data analysis and real-time decision making. But digital transformation and operational excellence, this is also very important in Industry 4. Aligning digital innovation with organizational goals. The integration of digital technologies into all areas of business, fundamentally changing how companies operate and deliver value to customers. Importance in manufacturing. Enabling manufacturing units to improve efficiency, agility, and customer satisfaction. Key focus areas. For digital transformation, the main area to be focused is leadership and change management, innovation culture, digital tools for excellence. Aligning digital innovation with organizational goals, strategic alignment. Digital innovation must be aligned with the company's long-term strategic objectives for it to deliver maximum value. The key steps for alignment are clear vision. Leadership must set a clear vision for digital transformation that aligns with organizational goals, which is very important. And next, investment in technology. Choose technologies that support the company's mission from operational efficiencies to customer experience. It clearly indicates that technology which we are going to involve there should not be a cheaper one or a better one, the required technology which we have to take. And continuous monitoring, regular assessment to ensure the digital strategy remains aligned with business goals. The role of leadership is provide guidance and set priorities, foster collaboration across departments, encourage adaptability and resilience within the organization. Once again, we'll discuss about the role of leadership in managing change. Leadership as change agents. Visionary leadership is key to successful digital transformation. Leaders must communicate the benefits and urgency of change to the workforce, managing resistance, addressing fears and uncertainties about digital change, implementing training programs to upskill the workforce, key leadership actions. Build a roadmap for digital transformation, involve employee in the process through collaboration, monitoring progress and provide feedback on digital initiative, creating a culture of innovation in manufacturing forms. Why innovation culture matters? In a rapidly evolving industry, fostering a culture of innovation ensures the company remains competitive and adaptable to change. Key elements of an innovative culture. Once again, leadership support. Top management must be champion innovation and be visible at the best. Employee empowerment. Give employees the autonomy to purpose and experiment with new ideas. Cross-functional collaboration. Encourage open communication and teamwork across different departments. How to foster an agile workforce. Promote continuous learning and development. Encourage experimentation and the acceptance of failure as a learning opportunity. Create flexible workforces. Create flexible work process to enable faster response to change. Steps to foster innovation in manufacturing. Encourage knowledge sharing. Set up platforms for employees to share ideas and solutions. Encourage employees to work with external partners or startups for fresh perspectives. Next, reward innovation is also very important. Implement recognition programs that reward creativity, problem solving, and innovating thinking. Adopt lean and agile methodologies. Encourage fast iterations and constant feedback loops in product development and operational process. The digital tools required for organizational excellence. Why digital tools matter? Digital tools help streamline operations, enhance decision making, and improve overall organizational performance. Key digital tools here are ERP, Enterprise Resource Planning Systems, integration of core business processes in real time, improves data accuracy and enhances decision making. Examples, SAP and Oracle ERP. Next, AI-driven workforce management. AI helps optimize resource allocation, reduce workforce turnover, and improve scheduling. Predictive analytics for better workforce planning and labor cost management. The examples are Workday and Kronos. Few examples are given, but there are so many other workforce management softwares. We'll have a look about ERP systems for operational excellence. ERP systems integrate critical business functions such as finance, HR, supply chain, and inventory management into unified platforms. Benefits of ERP in manufacturing. Real-time visibility into operations, streamlined workflows and improved collaboration, increased productivity and reduced operational costs. A manufacturing unit implements an ERP system resulting in a 20% reduction in supply chain cost and improved customer order fulfillment. Whether it will be inventory management, whether it will be production management, everywhere ERP is very much useful. AI-driven workforce management. AI for workforce optimization. AI algorithms can predict staffing needs, improve employee engagements, and enhance training programs. Key features of AI in workforce management. Predictive scheduling. AI analyzes historical data to forecast future demand and optimize staffing levels. Employee retention. AI analyzes employees' performance and satisfaction to predict turnover and improve retention strategies. Performance insights. AI tools provide real-time data on employee performance, helping managers make informed decisions. Example, a company uses AI-driven workforce management to reduce labor costs by 15% while improving employee satisfaction. Other digital tools for excellence, digital twin technology, virtual representation of physical assets for real-time monitoring, performance optimization, and predictive analysis. Here, data analytics and machine learning are also useful, which helps make data-driven decisions across operations from production to customer service. Challenge in implementing digital transformation. The most common challenge is resistance to change, overcoming the intrigue and fear of digital change among employees. Where employees may not be computer literates, they may protect it. Integration of new technologies, ensuring smooth integration of new digital tools with legacy systems. Data security and privacy, protecting sensitive data from cyber threats while embracing digital solutions. Lack of skilled workforce. It is very much important, which has to be addressed. Ensuring the workforce has the necessary skills to leverage new technologies. The key takeaways are digital transformation is vital for manufacturing firms to remain competitive, but it requires strong leadership and innovative culture and the right digital tools. Creating a culture of innovation and fostering an agile workforce is critical for successful digital transformation. Leveraging tools like ERP systems and AI-driven workforce management can significantly enhance operational excellence. Next, for Industry 4, your supply chain innovation is also very much important. Transforming transparency, traceability, efficiency, and resilience. Impact on supply chain. Industry 4 technologies are revolutionizing supply chains by making them more efficient, transparent, and responsive. The key technologies in supply chain innovation. Once again, IoT, blockchain, AI and machine learning, robotics, and automation. Smart supply chains, the role of IoT. Impact of IoT on supply chains. Real-time tracking and monitoring. IoT devices enable real-time visibility into inventory, shipments, and production lines. Predictive maintenance. Sensors on equipment help predict failures, minimizing downtime and improving asset management. Optimization of logistics. IoT enables route optimization and inventory management for greater efficiency. An example is a logistic company uses IoT sensors to track shipments in real time, reducing delays and improving customer satisfaction. Blockchain for transparency and traceability. A decentralized distributed ledger technology that ensures data integrity and transparency. How blockchain enhances supply chain transfer. Immutable records. Every transaction or event in the supply chain is recorded permanently, providing a trustworthy audit trail. Enhanced traceability. Consumers and businesses can trace products from raw material to final delivery, ensuring product authenticity and safety. Smart contracts. Blockchain automates and enforces contract terms without the need of intermediaries, reducing time and cost. An example is a food manufacturer uses blockchain to trace the origin of raw materials and provide transparency to consumers about the food supply chain. Efficiency gains through IoT and blockchain. In operational efficiency, inventory management, IoT provides real-time stock updates, reducing overstocks or stockouts. Process automation. Blockchain enables automatic verification of transactions, speeding of supply chain process. Cost reduction, reduced administrative cost due to automation, lower transportation cost through optimized routes and real-time tracking, faster response times. IoT allows for quicker decision making with real-time insights. Blockchain streamlines verification, reducing the time spent on manual audits. Retailers use IoT and blockchain to optimize supply chain processes, resulting in a 25% reduction in operational cost. Resilient supply chains preparing for disruptions. What makes a resilient supply chain? Adaptability to change, quickly respond to unexpected disruption. Risk mitigation, anticipate potential disruptions and have contingency plans in play. Collaboration across the supply chain, foster a cooperative environment among suppliers, manufacturers, and customers. How Industry 4 technologies support resilience. Real-time data analytics by using IoT and AI enable businesses to quickly detect and address disruptions such as supply shortages or transport delays. Blockchain for trust and visibility provides full transparency, which helps businesses assess risk and make informed decisions during disruptions. Automation and robotics maintain operations even with reduced workforce or remote management. Responding to COVID-19 with Industry 4 technologies, we are all aware that during COVID-19, there were several impacts on supply chain management. The impact of COVID-19 on supply chains, global disruptions, delays in manufacturing, raw material shortage, and labor shortage. Role of Industry 4 in response, real-time monitoring. IoT enables supply chains, provided real-time insights into disruptions and help businesses reroute shipments. Blockchain for traceability. Blockchain ensured product traceability and facilitated the rapid verification of new supply sources. Artificial intelligence and predictive analytics. AI tools help predict demand shifts and potential supply chain bottlenecks due to pandemic. An example is a pharmaceutical company uses IoT and AI to quickly respond to demand surges during the pandemic, ensuring timely distribution of critical products. Building a more resilient supply chain for the future. The lessons learned from COVID-19 are the importance of digitalization for faster decision-making and enhanced visibility. Resilience required continuous monitoring and the ability to pivot when necessary. Key strategies for future resilience. Diversification of supplies. Using digital tools to manage a more flexible and diversified supply base. Collaboration platforms, investing in tools for seamless communication between all stakeholders in the supply chain. Predictive technologies, using AI, machine learning, and big data analytics to predict and respond to future disruptions. A global electronic company leverages AI-driven supply chain tool to monitor supplies performance, reducing the risk of future disruptions. It is an example. Supply chain innovation in action. IoT in logistics. The challenge, a logistics company struggled with delays and inefficiency. Solution, implementing IoT sensors to track shipments in real time, improving delivery time and customer satisfaction. Outcome, 30% faster deliveries and a 15% increase in customer satisfaction. A decade ago, whenever a logistic company has taken a consignment. We don't know when it will reach us. But now, even starting from booking, we can trace the consignment, which was made with this IoT. Blockchain for traceability challenge. A food producer face challenges with product recalls and traceability. The solution is adopting blockchain to track products from farm to table, ensuring transparency and product safety. Outcome: improved consumer trust and reduced time for product recalls. The key benefits of Industry 4 in supply chain. Transparency. Blockchain provides a clear, unalterable record of transactions, making the supply chain more transparent. Efficiency. IoT and AI enable real-time monitoring, improving decision-making and reducing inefficiencies. Resilience. Technologies like IoT, AI, and blockchain help companies quickly respond to disruptions and minimize risk. Collaboration. Integrated technologies promote better communication and collaboration across the supply chain. Challenge in implementing Industry 4 in supply chain. Data integration. The challenge of integrating data from various systems, IOP, ERP, blockchain into a cohesive platform. Cybersecurity risk. The increased connectivity of devices and systems introduces potential vulnerabilities. Cost of implementation. Initial investment in technology can be significant, particularly for small businesses. Skill gaps. A shortage of skilled workers capable for managing and interpreting data from advanced technologies. Sustainability and environmental considerations are also matter in Industry 4. Leveraging technology for eco-friendly manufacturing practices. Why sustainability matters? Growing environmental concerns and the push for more sustainable manufacturing processes. Industry 4 offers the potential for manufacturing processes that are not only more efficient, but also more eco-friendly. Key areas of focus: sustainable manufacturing processes, circular economy principles, digital tools for waste reduction, energy efficiency, and recycling. Sustainable manufacturing practices in Industry 4. What is sustainable manufacturing? Manufacturing processes designed to minimize negative environmental impacts while conserving energy and natural resources. Industry 4 technologies for sustainability. IoT, real-time monitoring of production processes to reduce waste and optimize resource usage. AI and machine learning, optimizing production schedules, energy usage, and identifying areas for improvement in sustainability. Additive manufacturing, which is 3D printing, producing product with minimum material wastage. Automation and robotics, improving efficiency and reducing resource consumption through precision and waste reduction. How Industry 4 technologies reduce waste and energy consumption. Waste reduction, IoT sensors. These sensors will track materials throughout the production process and they will minimize overproduction or wastage. AI for process optimization. AI algorithms analyze production data to identify areas where material use can be reduced. And energy efficiency. Smart factory technologies. IoT-enabled missions automatically adjust settings for energy efficiency based on real-time data. Predictive maintenance. AI predicts equipment failure allowing the maintenance before energy-intensive breakdowns occur. Energy monitoring. IoT devices monitor energy consumption in real time, optimizing usage and reducing overall consumption. Impact of Industry 4 on environmental footprints. The major impact, reduction in carbon emissions. By optimizing energy usage and improving operational efficiency, Industry 4 reduces carbon emissions in manufacturing. An example for it, a factory uses AI to reduce energy consumption, leading to 20% reduction in its carbon footprints. Resource conservation. Real-time data analysis allows manufacturers to use raw material more efficiently, reducing the need for excess resource extraction. For natural resources, it is very much required. Cleaner production. Robotics and automation reduce human error and ensure more precise production, minimizing material wastage and environmental damage. And let us discuss about the circular economy. Circular economy principles and digital manufacturing. What is circular economy? An economic model aimed at eliminated waste and the continual use of resources. Products, materials, and resources are kept in use for as long as possible. Key circular economy principles are designed for longevity. Create products that last longer, are easy to repair, or can be upgraded. Now we can observe that our electronics are useful for 1 year or 2 years, and later we are throwing them, and e-waste is very high at present. Reduce, reuse, recycle. Minimize waste by reusing materials and recycling products at the end of their life cycle. Closed loop production. Ensure that the end-of-life products are returned to the supply chain for reprocessing into new products. How digital manufacturing supports the circular economy. Resource efficiency. Digital manufacturing tools such as AI and IoT can optimize the use of raw materials, reducing waste. Product lifecycle management. IoT for tracking. IoT devices track products and materials throughout their life cycle from creation to disposal, ensuring recyclability and reuse. Digital twins, virtual models of physical products allow manufacturers to simulate and test the longevity and sustainability of materials. Recycling and remanufacturing. Additive manufacturing. Uses to remanufacture parts, reducing the need for raw materials and encouraging the reuse of existing ones. Closed loop recycling. Advanced sensors and AI systems in the factory can identify recyclable materials and separate them from waste streams. The case studies, Industry 4 and circular economy. There are 2 case studies. One is of BMW's circular economy approach. BMW uses Industry 4 technologies like IoT and AI to optimize production process, reduce waste and recycle materials. The result with that is a 10% reduction in raw material consumption and increased usage of recycled materials in manufacturing. Case study 2, Philips products as service model. Philips uses a circular economy approach, designing products for longer lifespan, repairability, and recyclability. IoT and digital technologies track products usage to facilitate take-back programs. The result of it is reduction in e-waste and increased product lifespan. Environmental impact of Industry 4, benefits and challenges. The benefits are waste reduction, enhanced resource management, and reduced waste through IoT, AI, and digital manufacturing. Energy efficiency. Smart factories optimize energy consumption, contributing to low carbon emissions. Material conservation. Advanced technologies like 3D printing and AI-driven processes reduce the need for raw materials. Challenges: high initial investment. Transitioning to Industry 4 technologies requires significant capital investment. Data management and security. Managing the vast amounts of data generated by Industry 4 technologies while ensuring data security. Integration with legacy systems. Many manufacturers still rely on outdated infrastructure that is not easily compatible with advanced digital technology. Sustainability metrics and monitoring in Industry 4. Key metrics for sustainability. First one is energy usage. Monitoring energy consumption in real time to optimize production schedules and reduce energy waste. Carbon footprints. Using AI and IoT to track emissions and implement strategies to reduce the carbon footprint. Material waste. Real-time data analysis to minimize waste generation during manufacturing. Monitoring tools. Sustainability dashboards. Digital platforms that track and visualize sustainability metrics across production processes. AI and big data. They will help tools that analyze large sets of data to identify inefficiencies and areas for improvement in sustainability. Future outlook of Industry 4 and the green manufacturing revolution. Continued advancement. Ongoing research and innovation in digital manufacturing technologies will further reduce the environmental impact of production process. More industries are adopting circular economy practices supported by digital tools to achieve net zero emissions and resource conservation. The role of government and industry collaboration is very much required here. Collaboration between governments, industry leaders, and research institutions to create sustainable policies and frameworks for digital manufacturing. Industry 4 technologies like IoT, AI, and 3D printing are not just improving efficiency, but also contributing to sustainable manufacturing practices. The adoption of circular economy principles through digital manufacturing is future of sustainable and eco-friendly production. Industry 4 and the future of work. Transforming the workforce and promoting human-machine collaboration. Industry 4 offers significant opportunities for reducing waste, energy consumption, and environmental impacts in manufacturing. Circular economy principles are being increasingly enabled by digital manufacturing technologies, promoting sustainability across the supply chain. The transition to sustainable manufacturing practices requires continued innovation, collaboration, and investment in digital tools. The impacts on workforce. Industry 4 is radically transforming the way work is done, changing the skills required and influencing human-machine interactions. Key focus areas are evolving skills for Industry 4, human-machine collaboration, and the role of technology in reshaping job roles. Like how our ITIs are training fitters, helpers, turners, welders, which may not be useful in future. Transforming the workforce, evolving skills in Industry 4. Skills in demand for Industry 4. The skills are required are data science and analytics. Data-driven decision making requires professionals skilled in analyzing and interpreting big data, AI literacy, knowledge of AI and machine learning algorithms for automation, predictive analytics, and intelligent decisions. Robotics and automation maintenance. Technicians and engineers capable of maintaining, troubleshooting, and programming automated systems and robots. Cybersecurity skills. As factories and industries become more connected, experts in cybersecurity are needed to protect digital systems for cyber threats. Next, cloud computing. Expertise in managing cloud-based systems to enable scalable, efficient data storage and access. Digital twins and simulation. Understanding to digital twin technology and how to use simulation for better decision making in production processes. Examples of emerging roles in Industry 4. Data scientists, analyzing large volumes of data for connected devices to improve operational efficiency, quality control, and predictive maintenance. Robotics engineers, designing and maintaining robots used in automated production lines, ensuring their performance and integration into manufacturing systems. AI specialists, developing and optimizing AI algorithms that drive autonomous decision-making in manufacturing process, supply chains, and product design. IoT engineers, ensuring smooth integration of IoT devices into the factory, enabling real-time data collection and analysis for better insights. Protecting critical manufacturing systems from cyber threats. Cybersecurity experts protect the critical manufacturing systems from cyber threats, ensuring the security of data flowing through connected systems. Let us discuss about the need for reskilling and upskilling in Industry 4. Why reskilling and upskilling are crucial. Many traditional roles are being replaced or transformed by automation, AI, and robotics. Workers must adapt to new technologies to stay relevant and competitive in the job market. Training opportunities. The industry partnerships with educational institutions. There should be a bridge between the industry and the educational institution for specialized certification in AI, robotics, data science, and many more based on the industry requirement. Online learning platforms offering courses in machine learning, cloud computing, and digital tools for workers to reskill and upskill. Next comes to human-machine collaboration, synergy between workers and technology. What is a human-machine collaboration? A partnership where humans and machines work together to improve efficiency, innovation, and productivity. Machines handle repetitive, hazardous, or high precise tasks, while humans provide creativity, decision-making, and emotional intelligence. For instance, several times we hear that the reactors in pharmaceutical companies are making accidents. We can use these machines like robots or something. We can reduce the human loss. The benefits of human-machine collaboration is increased productivity. Machines perform the heavy lifting, while humans focus on strategic creativity or value-added tasks. Enhanced safety. Robots can take over dangerous tasks, reducing workplace accidents and improving worker safety. Higher efficiency. Human workers can focus on troubleshooting, monitoring, and improving systems, while automation handles routine tasks. Cost savings. Automation and AI reduces costs in operations, allowing workers to focus on higher value tasks and innovation. Examples of human-machine collaboration in Industry 4. Collaborative robots, which may be called as cobots, Cobots work alongside human workers in production environments, assisting in tasks like assembly, packaging, and material handling, while the human worker performs tasks requiring dexterity, decision making, or supervision. AI-powered decision support systems. AI systems analyze vast amounts of data and provide recommendations, but human operators make final decisions based on their experience and insight. Smart maintenance. AI and IoT sensors monitor mission health and predict failures. Maintenance workers supported by AI insight perform proactive maintenance, ensuring higher uptime and fewer disruptions. Design and prototype with 3D printing. Engineers collaborate with AI-powered design tools to create prototypes, while 3D printers make physical modules, which are then refined by human experts. How Industry 4 is changing work environment. Smart factories, digital technologies like IoT, AI, and robotics are creating smart factories where machines communicate with each other and with workers for optimal performance. Remote work and monitoring. Industry 4 technologies enable remote monitoring of factory processes, allowing workers to manage production lines from anywhere, reducing the need for physical presence. Flexible work roles. With the rise of automation, workers are shifting towards more flexible roles where they manage multiple tasks, including overseeing automated systems, troubleshooting, and system optimization. Collaboration tools, virtual and augmented reality, which are called VR/AR, systems are enhancing collaboration, allowing workers to interact with digital prototypes, missions, and other team members from different locations. Challenge in human mission collaboration. Overall reliance on missions. There's a risk for over-dependence on missions, which may undetermine critical thinking and problem-solving skills in the workforce. Next, job displacement. Automation and AI may replace certain manual labor roles, requiring companies and workers to adapt to new skill sets. Resistance to change. Employees may resist new technologies due to fear of job loss or unfamiliarity with new systems. Technology integration. Integrating new digital tools into existing work processes and systems can be challenging, requiring time and investment. To implement all these, leadership is very important. Let us discuss about the role of leadership in Industry 4 workplaces. Visionary leadership. Leaders must guide their organizations through technological transitions, emphasizing the benefits of human-mission collaboration and the need for new skills. Fostering a culture of continuous learning. Leaders must create an environment where reskilling and upskilling are integral to career development, ensuring that workers are well equipped to handle new technologies. Supporting workers in transition. Providing training and support for workers transitioning into new roles, ensuring they are confident and capable in their new responsibilities. Future of work, Industry 4 and beyond. The increasing role of AI and automation. The future workforce will increasingly collaborate with AI, with missions performing tasks that require high precision and repetitive work, while humans focus on strategy and innovation. The shift of knowledge-based roles. As automation takes over manual tasks, the demand for knowledge workers who can design, manage, and optimize AI and automation systems will increase. Long-term workforce transformation. Industry 4 will continue to evolve, creating new industries and opportunities for workers to adapt and grow alongside technological advancements. The conclusion, Industry 4 is reshaping the workforce by requiring new skills in data science, AI, robotics, and cybersecurity. Human mission collaboration is at the heart of Industry 4, offering opportunities for increased productivity, safety, and efficiency. Leadership, continuous learning, and upskilling will be key to navigating the changes and ensuring that workers thrive in the future of work. Call of action. Organizations must invest in workforce development and foster a culture of innovation to fully realize the potential of Industrial 4. Thank you. So with this, I conclude this. Hopefully, my presentation is easy to understand. Yeah, Dr. Rajesh. Yeah.
Yes, sir. Actually, your presentation is very elaborative and very insightful, sir. You have explained the concepts of business impacts of Industry 4.0, opportunities and challenges in a very detailed manner. We are very
Thank you.
grateful to you, sir. There is one question from the participants that whether Industry 4.0 depends on technology. I think the
Yes.
answer is obviously yes. Yes, sir. You can
Yes.
elaborate on that.
Yeah, I'll elaborate. Without technology, even Industry 3.0 is also totally depends on technology, but maybe mechatronics are not fully automation. In Industry 4, we require all types of technologies and skills, particularly as we discussed, IoT, AI, robotics, big data, cloud, blockchain, and all these technologies are required. Maybe the implementation may be different from one organization to another organization, but all these are 100% required in Industry 4, particularly for sustainability, environmental challenges, in the same way carbon footprints, and even for supply chain management. From sourcing of raw material, next comes to processing, production, packaging, inventory management, as well as logistics management. Means up to customer satisfaction, technology is required. I can tell an example. Suppose if you are searching for a product in Google, immediately we'll get several this one from Amazon or Flipkart through Google, where that product is available, because they are using AI. They are searching customers through Google. I think I'm clear about it.
Yes, sir. Definitely, sir. Actually, I would like to add that Industry 4.0 normally blurs the distinction between physical, digital, and biological systems also.
Yes,
in
sir.
a sense, yeah, more of integrating physical and digital along with the biological also is added in the 4.0. That is a new dimension. So it adds to the socio-economic context also. Sir, you
Yes.
have really provided us a very insightful explanation about all the latest technologies, especially your points about blockchain technology, how it will build trust and autonomy, and how it will enhances the transparency. They're all very noteworthy. So the icing on the cake is sustainability metrics, because the world is moving towards sustainability and the ESG frameworks. So definitely everything has to be measured in terms of managing the organizations. So your explanation about the digital twin technologies, which will help us to visualize the actual manufacturing in a simulated environment, that will reduces the many challenges while we are implementing the complex systems. So with your vast industrial experience and knowledge, you have given us a very insightful session. Sir, there is another question I just found in the chat box. I think it
Yes.
is. Sir, cloud-based technologies can also be vulnerable to cybercrime.
Yes, sir. 100% cloud-based technologies can also be vulnerable, and even big data technology. See, once when we are entering into technology, definitely there are certain vulnerabilities and cyber threats also. So that's what we discussed in this also. We required cyber security experts to prevent such. And one more question just now I observed from Mr. Jairam Gogula. Based on technology, the decisions are maybe rigid, but not flexible. Yeah, 100%. That's the reason I'm discussing about human mission interactions also. It's not that 100% automated this one, where the monitoring supervision will be done by human interfaces. So then only this can be. And one more, Harmohan Singh, with 140 million population countries, do you feel that adoption of Industry 4 might disturb the job demographics, and therefore we need to adopt it a slower pace? Or else do you think the pace is uncontrollable at our end, and instead global forces will force us to adapt faster? I'll explain you about it, sir. In fact, many MSME industries, particularly micro and small industries, are facing manpower challenges. Because though we have 140 million people, though we have unskilled manpower, they are not ready to work with micro and small industries. Everybody wants to work with a large industry, or they wanted to sit idle. For instance, even in the state of Andhra Pradesh, there are so many engineering colleges who are producing engineers regularly. But the person who passed engineering will definitely go to a core subject or some other subject. The person who fails engineering is also anticipating the same salary which his batchmate is expecting, his batchmate is getting. So they're not ready to work. Now in India, this is the major problem. Earlier, we have more manpower. Now our manpower are not ready to work, with which several industries are facing problems. That's the reason we may require automation also. For instance, I am in the industry for 25 years. 24 years back, I have around 25 to 30 employees. Now we are running only with 10 to 12 employees by making semi-automatic, because they are not ready to work. So definitely change is required at some place. Okay, any more?
I think we have done with the questions, sir. Actually, your
Yes.
explanation is very insightful, in the sense like job dynamics definitely will change.
Yes, sir.
Maybe some kind of jobs may be lost, but maybe some high-tech jobs may be evolved.
Yes.
So in that sense, continuous learning should be the core theme for the education institutions.
Yeah.
I mean, it is a faculty development program, all the faculty members must instill the self-learning attitude among the students, because learning cannot be stopped even after completion of their degrees. So in that context, yes, we take this particular presentation as a benchmark in order to understand all the technologies and how they're shaping up the industry 4.0 in terms of business impacts. Definitely business organizations going to be impacted, and you have elaborated about the changes and challenges for these new dimensions, and you have highlighted about the risk factors in this. So with this, once again, thank you very much, sir, for taking up of your time and elaborately presenting more than 60 slides you have prepared for this talk. We are very grateful to that. I'll be sharing this presentation with all the participants. So with this, on behalf of PP Siddhartha College of Arts and Science, I once again profusely thank our resource person. As I mentioned in the introduction, Sri Murli Vasireddy garu, Murli Krishna Vasireddy garu, an industry leader and a successful entrepreneur. Above all, he is guiding the government and industry and all other stakeholders in formulating the policies, as we strongly believe the good policies is definitely builds good institutions, and good institutions will normally foster the culture of innovation. In that sense, your leadership, we look forward in this part of the state of the Andhra Pradesh, sir. Thank you very much. And I also thank all the participants for participating in this particular FDP. And the feedback link was shared already. So I request all the participants to give your feedback link through the feedback link we just shared on the chat box. With this, we are signing off the session, and I look forward to the second day session tomorrow at exactly 6 p.m. And we have another 2 guests we have lined up, and they're also very senior members. I request all the faculty members to take advantage of the ongoing FDP. Thank you very much and good night.
Thank you for the participants for continuous listening, and thank you, Ms. Dr. Rajesh Jampala garu.
Sir, namaste. Namaste, sir. Good night, sir.
Namaste.
Thank you.
Good night, sir. Thank you.